So in this video, I'll be determining whether the matrix 2, 6, 0, minus 2, so this matrix is a linear combination of the following four matrices. In other words, 1, 0, 1, 0, 0, 0, 1, 2, 0, 0, 1, 0, and 0, 1, 0, 1. So just for rapidity and speed, I'll call this first matrix A1. Well, let's make it a big A. Big A1, A2, A3, A4. And let's call this here B. Okay, so I want to see if I can express B as C1 A1 plus C2 A2 plus C3 A3 plus C4 A4. Right, so I want to see if I can find four scalars such that the linear combination using those scalars, when I add them up, when I scale each of these matrices by the respective scalar and I add them up, I get the matrix that I want, B. So that's what it means for B, or this matrix here, to be a linear combination of these four matrices over here. So let's write out the system of well, let's first write out what this means in terms of matrices. So I have 2, 6, 0, minus 2, that's my matrix B, is equal to C1 times 1, 0, 1, 0, plus C2, 0, 0, 1, 2, plus C3, 0, 0, 1, 0, plus C4, 0, 1, 0, 1. Okay, now I want to make a system of linear equations using this, so create a system of linear equations. So I'm just gonna make each sort of entry of the matrix. So let's say 2. I'm gonna make that a sort of a linear equation with the respective entries of each matrix. So in other words, 2 is equal here to C1 times 1 plus C2 times 0 plus C3 times 0 plus C4 times 0. So I'll get C1 is equal, well, I'll actually just get C1 is equal to 2, because C1 plus 0 plus 0 plus 0, that's just C1. Okay, then my second system, or my second linear equation will be 6 is equal to 0 times C1 plus 0 times C2 plus 0 times C3 plus C4. So I actually know that C4 is 6. Then I'll get 0 is equal to C1 plus C2 plus C3. And then finally I'll get minus 2 is equal to C1 plus C2. Oh, sorry. That was the wrong entry. I'll get 0 plus 2C2 plus 0 plus C4. Right, so this is the system of linear equations I get. So already I know that C1 is equal to 2 just by inspection, and that C4 is equal to 6 also by inspection. So I can use this information in, so let me label these, 1, 2, 3, 4. So I can use this and replace in equation 4. So I can replace C4 as 6 in equation number 4, and I'll get minus 2 is equal to 2C2 plus 6. So if I just isolate for C2, I'll get minus 8 over 2, so C2 is minus 4. So now I have that C2 is equal to minus 4. And finally C3, I'll do it over here. I can use this that I just got here, and also the C1 here, and I basically plug C1 and C2 in 3 to solve for C3. So I'll get 0 is equal to 0 is equal to 2 plus minus 4 plus C3. So I'll get C3 is equal minus 2. So C3 is equal minus 2. So that means that I do get a result. So so my solution will be C1 is equal to 2, C2 is equal to minus 4, C3 is equal to minus 2, and C4 is equal to 6. So this is my solution. So that means that, yes, I can express my matrix. Remember that I called this matrix B. I can express B in terms of A1, A2, A3, A4. And let's just quickly check that my answer was right. So I had 2 minus 4 minus 2, 6. So 2 minus 4 minus 2, 6. Is that what I got? 2 minus 4 minus 2, 6. So let's check. So I'll do this over here. So I'll do this sort of mental calculation over here. This is it's good practice to check to see if your answer is right, because you obviously want to get the answer right. So let's see, I'll get 2 plus 0 plus 0 plus 0, that's equal to 2, that's right. Then my second entry, so that was that entry, then I'm doing this entry, I'll get 0 plus 0 plus 0 plus 6, that's obviously equal to 6, so that's good. Then this entry, I'll get 2 times 1 minus 4 times 1 minus 2 times 1 plus 0. So these cancel and they get 0. So that's also good. And finally, I'll get 0 minus 8 plus 0 plus 6. So I'm doing this entry. That's equal to minus 2, and that's what I have there. So that's also good. So I've shown that I can express B in terms of A1, A2, A3, A4 using these scalars.